What's going on, guys? Let's look at this problem right here. Here this question is asking a 10 horsepower 250 voltage shunt motor has an armature circuit resistance of 0.5 ohm and a field resistance of 200 ohms at no load, rated voltage and 1200 revolutions per minute. The armature current is 3 ampere at full load and rated voltage. The line current is 40 ampere and the flux is 5% less than its no load value because of armature reaction. Compute the full load speed. Here the question is asking for the full load speed, that is NFL, full load speed. First let's draw the circuit. RF, this is RG, and then here we have EA. Current is going downward, IA. Load current IL is going this way, and the voltage across this is VB plus minus. And this is a motor where EA is less than VT at no load. Now to find out EA no load, this is the formula: V load minus, actually VT minus IARA. VT is given right here, 250 voltage. 250 minus the current is given 3 ampere. 3 ampere times the resistance, that is 0.5 ohm. So 3 times 0.5, and that gives us 248.5 voltage. Okay, and voltage generated in the armature circuit due to the flux of the shorter field current can be calculated using this formula. First we have to find out. Okay, first we are going to calculate the EA no load over the speed no load, and EA also equal to Ka phi W. Now EA no load divided by the speed no load is 248.5. the speed no load is given right here, 248.5 we found out here, and speed no load is 1200 revolutions per minute. 1200 revolutions per minute, that gives us 0.207, and IF is equal to VT over RF. VT is 250 divided by 200, that is equal to 1.25 ampere. Now IA is equal to IL minus IF. I load is equal to 40 minus IF is equal to 1.25, and that gives us 38.75 ampere. And EA FL is equivalent to 250 minus 380.75, this full load, EA full load, 38.75 times 0.5. we use the same equation as here, VT minus IA times RA. Okay, VT minus IA times RA, here we use the current, this IA, okay, full load current. Actually IA current, IA is IL minus I full load, and that gives us EA full load. Now flux is 5%, so 0.95% of the flux has no load value. Our main purpose is to find out the speed, and EA FL over N speed FL full load is 95% has no load value, so we just have to multiply 0.95 times, okay, this one is this one is EAFL full load is 230.625 and 0.95 times this one no load value, we calculated it to be 0.207. If you multiply this one by 0.95 percentage, 95% actually, because 5% is less than flux is 5% less than its no load value. So 95% of the flux is 95% of the no load value. So if you multiply this one by 0.95, that gives us a full load value. So 0.95 times 0.207, and if you multiply, you will get 0.197. And here the speed is full load speed is what we are trying to find. Full load is equal to EAFL divided by 0.197, and that gives us 1170.685 revolutions per minute, and that is the full load speed. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.